This is the first fully functional Raspberry Pi plane. This Fokker DR-I. It consists of a PWM bank with 16 PWM outputs, a remote control receiver, a Raspberry Pi and a accelerometer. I'm not using the accelerometer quite now. I'm just redirecting all the inputs from the remote control receiver to the PWM. This is my debug output from the Raspberry Pi screen, so I'm having it on the HDMI. But I can also use this nice web view. So if I put my remote control here, the web view and so on, you can see I'm getting all the inputs from my remote control, throttle, and also the rudder. So the source code for this is also quite simple. It's written in the FOP programming language, which is easy to connect real-time changing values and to keep all the updates. So it compiles to Python code, but more about this later. I am having 4 read channels read from different PWM pins. So I'm having these GPIO pins where you see these resistors. The resistors directly go into the signal pins from my remote control receiver. And from this I am reading the values out. Then I am having this Raspberry Pi web output float where I can display these bars for each channel. So I can also like output the accelerometer values and whatever I think what I want to output. And then I'm writing to the I2C. And now let's make a simple code change. So if you see, my aileron is the wrong way around. So let's just invert the aileron. For this I will just have a interpolation. Simple interpolation. So float adds 2 floats, float difference takes the difference, and float interpolate output float interpolate ID output min, output max, input min, input max. So that's quite easy. Float interpolate. I'm having my pin, I call it for aileron, and I am computing output min is 1000. And output max is 2000, and my input is for aileron I. So I'm just using a different ID, and this interpolates from 2000 to 1000. So this way I inverted the access. And now I will rename my PWM read because the PWM contains the wrong value. And change it to I, aileron I. Then I hit make. And what I get now is a Python, a piece of Python code. So this main.py, and after we tried it, if it works, I can show you how the generated code works. So you see, just to get this small example running, you need a lot of Python code. So Python is a very complicated programming language. Copy. So then I run my main.py, and now I see I have in my debug output I have two ailerons, aileron I and the other aileron one. And if I now go left, alright, I'm going into the right direction. So what's behind this? I told you about main.py. Let's take a look at this. So what main.py does is it reads from the GPIO inputs. It outputs them in a web server front end with real-time capable service workers. And it also outputs them on the output board with 16 channels. So it's initializing the bus, it's loading the library for our PWM channel bank. We're having some variables initialized for our values. Then we have a loop for the web server that receives and sends all updated variables. Then we have our sub process which reads in the PWM inputs. You can see it in my other videos how I created the PWM real-time module. Then real-time read will read all these PWM inputs, and it will activate as well the channel, as well as propagate the new value to the web server. For our rudder, it's also nearly the same. Here, our aileron, this is the interpolation code, so you don't have to care about interpolation code. This is what FOP exactly does for you. It's very intuitive to write change 1000 to 2000 to 2000 to 1000. The code for it looks much more complicated. Then this is our web server, which shows all the components like our 4 input knobs, and with some CSS. And this is our web server implementation with the WebSocket code, which calculates what to output. Then we have the server running on port 1337, And we also have our debug output, which prints out the state of our internal registers. So, and then it runs the main loop, which cares about updating all the values. So the values only are updated when there's a new value, like waiting for interrupts or something like this. So that's it. And next time I will include the accelerometer to have our flight stabilizer. And as soon as I am confident enough that my flight stabilizer will correct all my errors, I will try to put this thing into the air. I already tested it. It really flies well. At least it has enough power to lift itself a few meters into height before I stop the motor to get it back to the ground. So that's it. And I will also work on releasing the FOP compiler to the public, but it still needs some preparation work, like a web-based IDE for the compiler, because the toolchain is kind of heavy. So stay tuned, and I will also make a video where I show you how to use the programming language for yourself.